Alright, welcome to the extra practice video. I hope you're watching this, okay? It says optional. I don't like options, so we're just going to do it. Okay, so these are problems a little bit harder, but it should be good practice in theory. Obviously, it's still insanely bright out and still right in my face, so it'll be fun. So, example number 1. Find the values of x and y in the diagram. Remember, 4 main theorems, okay? So, looking at this is kind of a tricky one. As you can tell, looking at this tiny little triangle right here, right? This side right here is the 2y. Now, it's really hard to interpret that, but that's the only way we can really work with it. So we kind of have a few different options here. And so, since this is 2 and this is 2, we know that this and this are the same. So we know that 2y is equal to x. And so that's all well and nice, but we can't really do anything with that, right? So we got to kind of work from there. So looking at the other triangle, right? So we made one equation. So equation 1. So looking at the other triangle, now the big one, notice they're all 1, which means it's an equilateral triangle. Okay? So if it's an equilateral triangle, it means that all the sides are the same, which tells us that x is equal to 8. Okay? And so now once you have this, then we can solve for this. So we have 2y is equal to 8, y is equal to 4. And that's it. So we really just applied 2 of those theorems, right? We used the, the corollary to the base angles theorem if the 2 angles are the same, the 2 sides are the same. And then we use the corollary to the converse that tells us that, hey, if all the angles are the same, then all the sides are the same. Okay? Not too bad. Number 2. Find the values of x and y. So, we have a few options here, but they're not all super nice. So let's see what we can do. So first off, these 2 are the same, which tells us that these 2 are the same. That's the base angles theorem, right? So I know that 8x minus 1 equals 6y plus 1. Okay, that's step 1. Doesn't really tell us a whole lot. But now, we actually have a second equation that we could use. We know that this is a triangle and we have all 3 angles, right? So what I can do is I can say, well, these 2 plus this equals 180. So this is equation 1. Equation 2 is that 8x minus 1 plus 6y plus 1 plus 22 equals 180. Okay? So here's the thing. This is a system of equations that you have to solve. I'm going to write system of equations. Now I'm not going to waste your time doing this in the video, but basically what you do is you solve for x or y here and plug it back in up here and get both answers. That's an Algebra 1 skill. Now, I'm not teaching it this year, but this can come up on like the ACT or the MCA, and so I wanted you to see it. If you don't know how to do this and you're interested in knowing how, won't be tested this year, make sure you reach out, okay? Again, we're just going to solve, you just solve for one variable here and plug it in up here, okay? Or there's like elimination methods or whatnot, okay? All kinds of options. So, going to move on from there. Number 3, find the perimeter of the triangle, okay? So, this isn't too bad. Now, if you think about it, this is 39 and this is 102, okay? Triangles make 180, so we might as well find that. So if you do this, what is that, 141? So this also has to be 39, which was, of course, the idea. So now, these 2 angles are the same, which means that these 2 sides are the same, okay? So we have an equation right there. We have that 2x plus 7 is equal to 5x minus 8. That's the equation that we get to write by the base angles theorem. Let's solve it. So 3x equals, what is that, 15? X is equal to 5. Okay? Now, is that the answer we wanted? No. We want the perimeter. So we're going to go ahead and plug it back in. So this side would be 30. This side would be 10 plus 7 is 17. And this side would be 25 minus 8, which is also 17. Of course, these are the same, right? So the perimeter is 30 plus 17 plus 17, which is 30 plus 34, which is 64. Okay? We'll put units just to be really, really careful. So, nothing crazy. That's a completely reasonable test question to ask you. Okay? Not like the previous one. Alright, it says you try, so I'm going to let you try it. You go ahead and do this on your own. Do on your own. Okay? It's the same thing, right? These 2 are the same, so these 2 are the same. Solve for x. Solve it. Okay? Let's do this one. Find the value of x and y. So, to start with, these 2 are the same, so these 2 are the same. Now it's tricky, because if you don't catch which ones are the base angles, then this is very impossible, right? So just make sure you draw a little arrow if that helps, that tells you where it is across from it, okay? So now I know that these two are the same, so I'm going to set an equation up, set them equal. Solve it. 4y equals plus 41 is 36. Y is 9. There's not enough room in this problem. Okay, so that's great, but it says solve for x and y. So the last part is, right, we know what y is. We know that we have 3 angles. Triangles always make 180. So we're going to plug in the 9 here. What is that? 54 minus 5 is 49. Okay, and this is 49, and certainly this is 49 as well. Yeah. So we have 49 plus 49. Doesn't here, so you can't mess that up. Plus the last one is equal to 180. Okay, and we can solve this. What is this? 98 plus 22 plus 12x equals 180. 120 plus 12x equals 180. 12x equals 60. X is equal to 5. So we found x and we found y. Okay, nothing too bad there. All right, on to some proofs. Okay, I know you love proofs, right? It's your favorite part of my class. So let's get some of these done. Again, they're really fulfilling, right? So if you're still sticking with this class and you're still hanging on, then you would know, right? Once you really understand what's going on, these proofs are not challenging. Okay, they're scary, but they're not challenging. So let's go through it. So we're going to use the picture. We're going to mark up the picture as we're going through it. So first off, we're given that AB and AE are the same. Okay, this is actually two-stepper proof. Two-stepper. So step 1, start with a given, right? So this is our statement. And this is our reason. I'll put S and R next time. So to start with, AB is congruent to AE. And that reason is given. Okay? Now, because the two sides are the same, the two angles are the same. So if you look back into 5.4, that would be the base angles theorem. If the two sides are congruent, then the two opposite angles are congruent. So we can write that angle B is congruent to angle E by the base angles theorem. This is a straight application of that theorem, nothing to it. Super, super easy, right? Okay, so that's a wonderful test question. You could do that in 2 seconds. Okay? On to the last example. A little more challenging, right? This looks like an old school pyramid to me. It's not, it's just a triangle, but okay. We're going to start with ACD. ACD, what is that? Angle ACD right here is the same as ADC. So these two are the same. And we need to show that triangle ACD is isosceles. So this is a really silly problem, right? So let's go ahead and do it, because it's really obvious. So first off, angle ACD is congruent to angle ADC. That's given. Again, these are your statements. These are your reasons. This part of here is completely irrelevant. Okay? So from this, now I know that these two sides are the same, right? And I know that because of the converse to the base angles theorem. So we're going to write AC is congruent to AD. Okay? And that says if two angles of a triangle are congruent, boom, boom, then the opposite sides of them are congruent, boom, boom. So that is the converse to base angles theorem. So that's not, you're done, right? That's not what I asked you to prove. It says prove it's isosceles. So we're going to write triangle ACD is isosceles. And what's the reason? Well, that's the definition of isosceles. Two sides are congruent. We've defined it, right? So super, super easy. Those proofs are completely reasonable. They're not like super confusing. So don't be stressed out by them. Don't be overwhelmed by them. Nothing to it, okay? Thanks for watching. Have a wonderful week.